Welcome back. This is the second lesson recording for IM2, February 22nd, 2021. Okay, the most common mistake when you're solving this equation is for students to say x plus 5 is equal to 16 and x minus 1 is equal to 16. Okay, the reason you cannot do this is, just think about it. If you're saying that x plus 5 is equal to 16, you're saying that this is equal to 16 and this is also equal to 16. 16 times 16 is never going to be equal to 16. Okay, it's going to be a much bigger number, right? So this straight away tells you that this cannot be true. This is not correct. Okay, you cannot do this. The only reason we can set each of the factor to be equal to 0 is because 0 is a very special number. Any other number, what are the two ways that two numbers can multiply to 16? It's infinite different combination. It could be 2 and 8, it could be negative 2 and negative 8, it could be 1 and 16, or negative 1 and negative 16, and so on and so forth. So it's just infinitely many, so that does not work. So therefore, we need to first set the equation to be equal to 0. So how do I do that? I need to multiply up the left hand side. So using FOIL, that becomes x times x is going to be equal to x squared. The inside or outside, x times 1, negative 1 is going to be negative x. Inside is plus 5x, and then 5 times negative 1 is negative 5 is equal to 16. I am going to bring the 16 to the left hand side, okay, by subtracting 16 from both sides as well as combining like terms. So that becomes x squared. Negative x plus 5x is going to be positive 4x. Negative 1 minus 16 is going to be negative 21 is equal to 0. Now that it is set to be equal to 0, now I can factor this. And I know that the only way I can do this is by putting x and x there. What are the two numbers that multiply to negative 21 but that add to 4? So since it's negative, that means one's going to be positive, one's going to be negative. So the difference between the two numbers is going to be 4. So that's going to be negative of 7 and 4, 3, or 7 and 3 I mean. Okay, and I want the sum to be positive 4, so I know the bigger number has to be positive and the smaller number has to be negative. So x plus 7 times x minus 3 is equal to 0. From here I know that x plus 7 is equal to 0 or x minus 3 is equal to 0, and therefore x is going to be either a is going to be negative 7 or x is going to be 3. And I can always check this by substituting these values back in there, and that will give me a true statement. So negative 7 plus 5 is going to be negative 2. Negative 7 minus 1 is going to be negative negative 2 times negative 8. That's going to be positive 16, and so on. Okay, so my two solutions are negative 7, 3. Okay, what are the geometric application of the method that we just used? Well, the most common application is finding the area of a rectangle. If you know the area of a rectangle is 40 units squared, then we're trying to find the length of each of the sides. Okay, and we're told that one length is x, the other length is x plus 3. So let's set this up. Okay, so what is the area going to be? Area is always going to be length times width of a rectangle. The length is x plus 3, or let's say x, and x plus 3 is the width. And we're told that the area is 40. So we're told that x times x plus 3 is equal to 40. Now, how do I do this? Remember, I can't set each of the factor to be equal to 40. I need to expand this out. That becomes x squared plus 3x is equal to 40. I don't want this to be equal to 40. I want it to be equal to 0 so that we can factor. So I want to bring the 40 to the other side of the equal sign by taking the negative of 40. That 40 positive 40 becomes negative 40 on the left hand side, so that becomes x squared plus 3x minus 40 is equal to 0. From here I factor these two, and the only way I can do this is if I put x and x here. What are the two numbers that multiply to negative 40 but add to 3? Since it's negative 40, I know that one's going to be positive, one's going to be negative, and the difference between those two numbers is going to be 3. Okay, so 20 and 2, the difference is not going to be 3. Okay, so what are the 4 and 10? That's still not going to work. What about 8 and 5? That would work. 8 times 5 is 40, and the difference between 8 and 5 is 3. I am going to want the sum to be positive 3. That means I want the bigger number of the two, 8 and 5, to be positive. The bigger number is 8, the smaller number is 5, so that those are my two numbers. That means x plus 8 is equal to 0, or x minus 5 is equal to 0. So this left hand side tells me that x is equal to negative 8, or x is equal to positive 5. Now think about the answers you've found. Okay, can you ever have a negative length? No, you cannot. So you disregard that. The only solution is the length is equal to 5, so x is equal to 5 in this case. So x is equal to 5, 5 is the length, and this 5 plus 3 is going to be 8. 8 is, so it's going to be 8 times 5 is the only length. Okay, we're going to move on to the new method, which is solving quadratic equation by square rooting. Before we do that, I want to have a quick review of the square root. Okay, and we've done this before in a couple of lessons ago, so I'm just going to go through this quickly, and I am not going to ask you to tell me in the private chat. Okay, what is square root of 9? Hopefully you're going to tell me that it is 3. What is square root of 16? Same way, 4. Okay, what is square root of 32? Well, 32 is not a perfect square, so the only thing I can do is simplify it as square root of 32 is same as 16 times 2. So, and I'm breaking up as 16 and 2 because 16 is a perfect square. So square root of 16 times square root of 2. Square root of 16 is 4. 4 times root 2 is same as 4 root 2. What about square root of 7? Well, 7 is not a perfect square, and it does not have any factors that are perfect squares, so it remains as square root of 7. We also learned that square root of negative 9 is, we're looking for two numbers that multiply to negative 9. Well, 3 times 3 is positive 9, so that number cannot be 3, and negative 3 times negative 3 is also 9, so that number cannot be negative 3. So we know that no real number solution. This is there is no real number solution for this. So you can't have a square root of negative number. Okay, so for now we're going to say no real number solution. Later on we're going to learn about complex numbers, and likewise, because it is a square root of negative number, we're going to say no real numbers. Alright, so then let's extend this to new solving strategy. What is the solutions to if I have x squared is equal to 25? Okay, I want you to do the work in your notebook and tell me in private chat. Okay, so you can write square root of 5 as you can type sqrt parenthesis 5 instead of square root of 5 if that's what you want to communicate. Okay, so let's start off with easy ones. So what is square, if you have x squared, what is the solutions to x squared is equal to 25? If the question ever asks you to solve or what is the solution, that means we're looking for the value of x that makes this equation true? What are the values of x that makes this equation true? So we're asking, what is the value if I have, so I'm looking for x squared is really same as x. So we're asking what two numbers multiplies to itself becomes 25. X times x is equal to 25. We know that 5 times 5 is 25, so x can be 5, but we also know that negative 5 times negative 5 is 25, so x can be negative 5 also. So we can write this as x is equal to plus or minus 5. Okay, so this tells me it could be positive or it could be negative. This plus or minus sign means it's taking into account that two different options. So algebraically, what you can do is you can take to get rid of squaring. What is opposite of squaring? We can undo squaring by taking a square root. Square root is undoing the positive, undoing the squaring. Okay. However, when you're dealing with taking a square root of a variable, you need to put plus and minus on the right hand side. Okay, so square root and square, they cancel each other out. On the left hand side you're left with x is equal to, on the right hand side you're left with plus or minus. What is square root of 25? That is just 5, and that's what you get. Alright, what about this? X squared is 100. Again, you can take a square root of both sides, but when you do that with the variable inside the square rooting, okay, the only thing is you need to put plus or minus, because now we're dealing with variable being squared, so it can be positive or negative, and you need to take that into account. So that becomes x is equal to plus or minus, what is square root of 100? That's just going to be 10. Okay, what about this? Pause the video and see if you can do them yourself. Okay, so I have square root of x squared is equal to 15. Okay, so I want to solve this or find the solution. Again, I take a square root of both sides, but since I'm taking a square root of both sides with a variable inside, so I need to take into account it could be positive or negative. So that becomes the left hand side, the square root and square cancels out, and you're left with x on the left hand side of the equal sign, and plus or minus. Okay, square root of 15. Can we simplify square root of 15 as, this is not a perfect square, nor does it have any factors that are perfect square, so that leaves as square root of 15. You can't do anything with it. Okay, so what about this? Okay, the first thing is, we know that 3 is being multiplied to x squared, so what we can divide both sides by 3. And that cancels out to x squared is equal to 15 divided by 3 is 5. Now I can take square root of both sides. Remember, when I take a square root of both sides with a variable inside, I need to put plus or minus on the other side. So that becomes x is equal to plus or minus square root of 5. I want you to take notes on this. Okay, this is where I'm explaining all the steps. So if you have x squared minus 3 is equal to 3, in this case, we want to add 3 to both sides so that you rewrite the equation as x squared. Just x squared is equal to some constant. That means a number, okay? And it has to be a positive number for now, because we can't have it take a negative square root of negative number. So it has to be positive. If x squared is equal to some positive number, then you can use this method. Then you apply the square root on both sides. Make sure to include both plus and minus version by adding the plus and minus when you take the square root of both sides, and then you simplify. Okay, so x is equal to plus or minus 4, or x is equal to 4, or x is equal to negative 4. So please pause the video and see if you can solve these two equations now, and I will show the answers in the next lesson recording.